Have a nice day everyone. I am Alvin G. Benegas and today's video is all about other chi-squared tests. In the previous discussion, we have learned that the formula for the chi-squared goodness of fit test is chi-squared is equal to the summation of O minus E squared over E, wherein O is the observed frequency and E is the expected frequency. Under this lesson, there are two things to remember. The first one is that the data are obtained from a random sample. And the second one is that the expected frequency for each category must be 5 or more. We also have learned that under test of normality, the null hypotheses are H sub 0, the variable is normally distributed, and H sub 1, the variable is not normally distributed. Now let's proceed to our topic, and our topic is chi-squared test using contingency tables. Under this topic, there are two subtopics. These are test for independence and test for homogeneity of proportions. Now what is table of contingency? When data are arranged in table form for the chi-square, the table is called a contingency table. A contingency table is designated as an R by C or rows by columns table. In this case or in this figure of contingency or table of contingency, R is equal to 2. These are row 1 and row 2. And C is equal to 3. These are column 1, column 2, and column 3. Hence, this table is a 2 by 3 contingency table. Each block in the table is called a cell and is designated by its row and column position. Therefore, in this table of contingency, there are 6 blocks or 6 cells. These are C sub 1 and 1, C sub 1 and 2, C sub 1 and 3, C sub 2 and 1, C sub 2 and 2, and C sub 2 and 3. The degrees of freedom for any contingency table are row minus 1 times columns minus 1, that is, df is equal to r minus 1 multiplied by c minus 1. In this case, 2 minus 1 multiplied by 3 minus 1 is equal to 1 multiplied by 2, which is equal to 2. Therefore, df is equal to 2 in this table of contingency. The reason for this formula for df is that all the expected values except 1 are free to vary in each row and in each column. Now let's proceed to test for independence. The chi-squared independence test can be used to test the independence of two variables. And here is the procedure for chi-squared independence and homogeneity test. Step 1 is to state the hypothesis and identify the claim. Step 2 is to find the critical value in the right tail using the table G or the chi-squared table. Step 3 is to compute the test value. To compute the test value, first is to find the expected values for each cell of the contingency table using the formula E is equal to row sum multiplied by column sum over grand total. And to get the expected value, to find the test value, use the formula chi-squared is equal to the summation of O minus E squared over E. And step 4 is to make the decision. Step 5 is to summarize the result. And to further understand, here is an example. College of Education and Place of Residence. A sociologist wishes to see whether the number of years of college a person has completed is related to her or his place of residence. A sample of 88 people is selected and classified as shown. And here is now the given table of contingency. And it shows here that there are 3 rows urban in the first row, suburban in the second row, and rural in the third row. There are also 3 columns. In the first columns are no college, and in the second column or column 2, 4-year degree, and in the third column is advanced degree. At alpha 0.05, can the sociologist conclude that a person's location is dependent on the number of years of college? And here is now our solution. Step 1 is to state the hypothesis and identify the claim. And these are the hypotheses, or the null hypothesis is a person's place of residence is independent of the number of years of college completed. And H1, a person's place of residence is dependent on the number of years of college completed. And this is now the claim. Step 2 is to find the critical value. The degrees of freedom are 3 minus 1 multiplied by 3 minus 1, since there are 3 rows and there are 3 columns. Therefore, df is equal to 2 multiplied by 2, which is equal to 4. And now using the table G, or the chi-squared table, under alpha 0.05 and degrees of freedom 4, the corresponding critical value is equal to 9.488. Now let's move to step 3, compute the test value. To compute the test value, first is to compute the expected values in each cells or each block. And now using the given table of contingency, here is the solution in step 3, wherein the expected values are 11.53, 13.92, 9.55, 10.55, 12.73, 8.73, 6.92, 8.35, and 5.73. Since all the expected values are equal or greater than 5, we can now proceed to step 4. But before moving to step 4, let us first compute the test value using the formula chi-squared is equal to the summation of O minus E squared over E. And the test value is then 3.01. And now step 4 is to make decision. And the decision is not to reject the null hypothesis, since 3.01 is less than 9.488. And the last one is to summarize the result. Since the null hypothesis is not rejected, there is not enough evidence to support the claim that a person's place of residence is dependent on the number of years of college completed. And now let's move to test for homogeneity of proportions. The second chi-squared test that uses a contingency table is called a homogeneity of proportions test. In this situation, samples are selected from several different populations, and the researcher is interested in determining whether the proportion of elements that have a common characteristics are the same for each population. The sample sizes are specified in advance, making either the row totals or column totals in the contingency table known before the samples are selected. To further understand, here is an example. Lost luggage on airline flights. A researcher selected 100 passengers from each of 3 airlines and asked them if the airline had lost their luggage on their last flight. The data are shown in the table, and this is now the given table of contingency, wherein there are 2 rows. In the first row, the answer is yes, and in the second row, the answer is no, wherein there are 3 columns. In the column 1 is airline 1, in the column 2 is airline 2, and in the column 3 is airline 3. At alpha 0.05, test the claim that the proportion of passenger for each airline who lost their luggage on the flight is the same for each airline. And here is now our solution. Step 1 is to state the hypothesis. H sub 0, P sub 1 is equal to P sub 2, which is also equal to P sub 3. In H sub 1, at least one mean differs from the other. Step 2 is to find the critical value. Since there are 2 rows and 3 columns in the given contingency table, DF is equal to 2 minus 1 multiplied by 3 minus 1, which is equal to 2. And now using table G, or the chi-squared table, under alpha 0.05 and degrees of freedom 2, the corresponding critical value is then equal to 5.991. And step 3 is to compute the test value. First is to compute the expected values. And from the given contingency table, here is now our solution for step 3. And the expected values are 7, 7, 7, 93, 93, and 93. Since all the expected values are greater than or equal to 5, we can now move to step 4. But before moving to step 4, let us first solve the test value. Using the formula, chi-square is equal to O minus E square over E. And the test value is then 2.765. And now let's move to step 4, which is to make the decision. And the decision is not to reject the null hypothesis, since 2.765 is less than 5.991. And the last step is to summarize the result. Since the null hypothesis is not rejected, there is not enough evidence to reject the claim that the proportions are equal. Hence, it seems that there is no difference in the proportions of the luggage lost by each airline. In this topic, there are 2 important formulas. These are the formula for the chi-square and the formula for the expected values. And the formula for chi-square in this topic is equal to the summation of O minus E squared over E, wherein O is the observed frequency and E is the expected frequency. And the formula for expected value is equal to row sum multiplied by column sum over the grand total. And that's the end of my video presentation. Thank you for watching.